Alright, so today I want to talk about Newton's third law problem, and that involves action-reaction forces. And you're also gonna have to calculate some stuff like acceleration and the force applied. So you're gonna definitely have to use a net force equation. Net force equals ma. And basically the question says two buckets of nails are hung one above the other and pulled up to a roof by a rope. Each bucket of nails has a mass of 5 kilograms, and the action-reaction force between the buckets is 60 newtons. Calculate the acceleration and the force applied by the worker lifting them up. So first thing I'm going to do is I'm going to draw kind of like a free body diagram. First I'm going to draw it where you see it as two objects, but I'm also going to draw another one where it's just one object because they're both moving at the same rate. They have the same acceleration, so you can see it as one big block of mass. So what I'll do is make one block here. That's to the roof. And I'm gonna call this box A, and I'm gonna call this box B. It mentions the action-reaction force. So because of this action, there's gonna be a reaction that A is being pulled up by the applied, but that also pulls up B. So we can call this force A on B. And the box B is also pushing down on box A, so we'll label this, and they're the same, but we'll label this as force B on A. And let's calculate the acceleration. First, what I'm gonna have to do, this is where you're gonna have to look at it as one system, but we're gonna go back to this. So you look at it one system now, and both masses combined is 10 kilograms. Forces acting on this are force of gravity. It's also here. And another force is the force applied from the worker. Now what I'm going to do is I'm going to input this into a net force equation. So F net is equal to force applied plus force of gravity. We can actually find force of gravity. We have a mass, and we know that's just going to be 10, which is the mass, times 9.8. Oh, yeah, I forgot. Should probably make a compass. Up is positive, down is negative. Because down is negative, we'll make this negative. This is going to give us negative 98 newtons. So now we have our net force equation as F net is equal to Fa minus 98. Can put this F net into Ma. Ma equals force applied minus 98. Mass here is 10, so 10A. We're just going to leave it like this because there's two variables, so we can't solve it right now. But this is going to be our equation to solve for force applied later. So that's our one equation. 10A equals force applied minus 98. If we want to isolate for force applied, we can do 10A plus 98 is equal to force applied. Now what you want to do, once you found that, you want to isolate one of the blocks from here. Personally, I'm going to isolate box B. What that's going to help you is, since it's a system and they all have the same acceleration, if you find the acceleration of this, then you also have the same acceleration for this to find applied force. So this is 5 kilograms. This is box B. Force is acting as gravity. And this is force A on B, which we know in the question what it is actually. It says it's 60 newtons. So we can label this as 60 newtons up. Force of gravity is just 5 times 9.8, which is equal to 49 newtons down. So this is going to be negative. Now make another net force equation. F net B is equal to F A on B plus force of gravity. You can make this into MA B is equal to 60 newtons, which we got from there. And then minus 49 since down is negative. And we also have the mass, so we can put in 5A is equal to 60 minus 49, which is 11. Acceleration is going to be 11 divided by 5. That's going to be roughly 2.2 meters per second squared up. So we already found the acceleration. So we found the acceleration. Now what we're going to do is use the acceleration and sub that back into our equation to find force applied. If I just bring that equation over here, so it's 10A plus 98 is equal to force applied. 10A times 2.2 is just 22. 22 plus 98 is equal to force applied. That's going to give us 120 newtons. Since it's a positive, we know it's up, so those are our final answers. Force applied from the worker is 120 newtons up, and the acceleration is 2.2 meters per second squared up. That's how you solve Newton's third law problem involving two action-reaction forces, and also where you can either choose to look at it as one system or two individual objects pulling each other up. And we actually use both of these to try and solve for both variables, so I think that was pretty good. But yeah, okay.